Good morning, Section F. My name is Afshan Chandani, and this is the evaluation report for Team Incendio, which consists of myself, Kyle Mulholland, and Jesus Pacheco. In this presentation, we'll go over the problem description, our three design concepts, our evaluation method, and finally the design we ended up choosing. As far as the track is concerned, the objectives of the robot are best described by the function tree. Our main function is to score points, which we can achieve by doing these 7 subfunctions: extending to the center, retracting from the center, sensing the wall drop, placing the tennis ball, moving the dog bone, collecting gems, and not collecting squash balls. We also have several desired robot qualities that are mandated by the rules, such as being boxable, easy to set up, and durable for multiple runs. This is an image of design concept 1. The selections from the morphological chart that make up concept 1 are extending to the center with gravity, retracting using a winch, sensing the wall drop with time, placing the tennis ball with a motorized arm, moving the dog bone with a passive hook, collecting the gems with a passive filter system, and not collecting the squash balls by redirecting them into opponent territory. The advantages of this system are that it has proven squash ball avoidance, it's easier to box since there are no sensors extending out to the front, and it reliably secures the dog bone with its hook. The disadvantages are that it's harder to retract due to the amount of weight on the end. It's not sensing the wall drop, which could potentially lose us points for the Grindelwald challenge, and it's slower to extend since it relies on gravity and the lubrication of the drawer slides. This is an image of design concept 2. The selections from the morphological chart that make up this design concept are extending to the center with pneumatics, retracting using a counterweight, sensing the wall drop with an IR sensor, placing the tennis ball using a ramp, moving the dog bone with a pneumatic punch, collecting the gems with a passive system, and not collecting the squash balls by using an entry filter. The advantages of this system would be that it does sense the wall drop, which can gain us some extra points. It's fast to extend by using the pneumatic piston, and it pushes the dog bone into an enemy area, which gives them negative points. Disadvantages are that the counterweight was a difficult system to retract the entire robot. The squash ball avoidance system was not proven to be reliable, and the dog bone movement was also not proven to be reliable with the pneumatic piston. This is an image of design concept 3. The selections from the morphological chart that make up this concept are extending to the center with gravity, retracting using a pneumatic pull, sensing the wall drop with a touch switch, placing the tennis ball with a motorized arm, moving the dog bone using a passive hook, collecting the gems with a motorized roller, and not collecting the squash balls with the placement of that same roller. The advantages of this system are that it does sense the wall drop, which can gain us some extra points. It's easier to set up since it requires no solenoids or mouse traps. It reliably secures the dog bone with its hook system. And the disadvantages are that it's harder to box because the sensor extends so far out front. The retraction system was not proven to be reliable with the pneumatics, and again, it is slower to extend since it relies on gravity and lubrication of the drawer slides. In the end, we put all of these designs through an evaluation matrix. The criteria that were given the highest importance were things mandated by the rules, such as being boxable, durable, and extending and retracting from the center. Most of the scoring elements were given a rating of 8, such as collecting gems, not collecting squash balls, and moving the dog bone. But the entire tennis ball subsystem was given lower ratings since this system does not give us guaranteed points and therefore is not as important in creating an effective robot as the others. In the end, design 1 was the winner with a relative total of 0.75. The other two designs have relative totals of 0.59 and 0.66. This is an image of design 1, our chosen design, in a competitive setting. This is an image of the extension subsystem. As you can see, there's a pneumatic piston that lifts a pin, which allows the system to extend forward. This is the dog bone collection system, where this hook will be pulled back into the dog bone, which allows it to retract into the base. This is the gem and squash ball filtering system, where the gems and balls will be redirected into this filter. The gems will fall through, and the balls will get redirected down the ramp into opponent territory. This is the tennis ball placement system, where this motor will turn this arm and flip the tennis ball into the center. And finally, this is the retraction system, where this motor and pulley will act as a winch and pull a string which will retract the entire front into this starting zone. Thank you for listening. Are there any questions?